Welcome to the video lesson on the cosine law, also known as the law of cosines. And just like the sine law, the cosine law is a tool that we can use in a non-90-degree triangle. And specifically, there are two situations in which we would not be able to use the sine law. Remember that the sine law requires one pair of side and angle that are opposite each other. So in this situation here, which is called an SAS, which stands for side, angle, side, and the order is important. It means that there's a side that we know, then an angle, and then a side. There are two sides, and it has to be the angle between those two sides. In a case like this, if I tried to set up the sine law, this pair of side and angle has an unknown. So I would need one other pair where I know the side and the angle, and it doesn't happen here because I don't know this angle opposite the 8, and it doesn't happen here because I don't know the angle opposite the 10. So no matter how I would try to set up the sine law, and you can pause and try it if you like, we would have two unknown values and it would not be possible to solve. So in a case like that, we have another tool that we can use, and it's called the cosine law. The cosine law looks like this. This is the formula. C squared equals a squared plus b squared minus 2 times a times b times cos capital C. And if you cover up this part here, it looks a lot like Pythag. C squared equals a squared plus b squared, but it has this kind of correction factor that allows it to work for non-90-degree triangles too. So how do you know which is which? Well, the most important thing is that this side length C and this capital C have to be opposite each other. So what's important is that if you're looking for the side, you have to make sure that that unknown goes here because it has to be opposite this angle here. When I plug in that angle, that has to be capital C, and so this lowercase c is the side length that is opposite that angle. And which is A and B doesn't matter because we're squaring them and adding them. It doesn't matter what order we do that in. And here we're multiplying the two of them. It doesn't matter what order we do that in. So the most important thing is that we plug in that C opposite the 52. So when I plug this in, I would have x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cos 52. And this whole bit here, 8 squared plus 10 squared minus 2 times 8 times 10. This whole part I can do in one shot in my calculator, and it'll give a number that will be 8 squared, will give me x squared. So this whole number, which is approximate because cos 52 is an irrational number and I'm cutting it off, is going to give me the x squared, and then I'll have to take the square root to figure out the side length, and in this case it's approximately 8.09. If you want to pause and try to plug in this set of calculations on your own to see whether or not you can do that properly, you can verify to see that that's your answer. And I'll show you one other example. There's one other way to use the cosine law. So this first one was an SAS. There's another way, which is an SSS. It's where you have all three sides. And the formula is the same. This would be a case in which we're looking for an unknown angle. The formula is the same. I'd set it up the same way. C squared equals a squared plus b squared minus 2ab cos c. But now when I'm plugging things in, remember this C and this C are the same letter, so they have to be a side and angle opposite each other. If I'm looking for this angle here, that's going to be my angle that I'm plugging in with the cos, which means that this lowercase c, the one that's on its own side of the equal sign, has to be the side length opposite that unknown angle. I'd have to plug in the 9 there. It doesn't matter where I plug in the other two sides. But this here, when I plug it in, this 9 has to go opposite that angle. So this would be 9 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cos theta. And here, the order of operations is a little bit different because this cos theta, that's an unknown. I can't group that together with the 8 squared and the 10 squared because I want to isolate my unknown. I have to do a little bit of algebra. I've got to bring the 8 squared and the 10 squared to the other side. So what I can do is I can group together the 8 squared plus 10 squared, 64 plus 100. I can multiply 2 times 8 times 10. But these two things here, this is not equal to 4 cos theta. Don't make that mistake because this one has an unknown in it and this one does not. So what I need to do, like I said, is isolate the theta. That means bring the 164 to the other side. So subtract 164 from both sides. If you want to pause and think through what you would do next algebraically, you can give it a try. But if I want to isolate this theta, I've got to divide both sides by negative 160. The negatives cancel. And then because I have an unknown angle, just like when we were doing SOHCAHTOA, I'll have to do an inverse cos function. I'll have to do cos negative 1 of this entire thing. And I'll get an angle that's an approximation because it's an irrational number. Those are the two ways to use the cosine law.